So today we're going to be looking at scatter plots. So does anyone have any questions or anything before we get started? Okay, so like I said, today I'm going to be reviewing scatter plots and oh, sorry, I'm in the wrong. All right, so we're going to look at, first of all, what is a scatter plot? So scatter plot is a way to represent data. So usually you would plot points. In this case, this is an example of a scatter plot. Usually, if you are graphing real data, you would have units here and here, but I just wanted to remind you what a scatter plot is. When you have a scatter plot, one thing that they talk about is a correlation coefficient, which means how good does that data make a line. So if you look at this graph right here in the top left corner, they might ask you, does this have a positive relationship, a negative relationship, or no relationship at all? So really, if you were to draw a line that somewhere kind of represented this data, it would look like this. And so what type of slope does that line have? Positive, negative, no slope, zero slope? So this would have positive slope. So we would say that there's a positive relationship between the points. On this graph right here, if we were to draw a line, it would look something like this. So we would say that that has a negative slope or negative relationship because the line is sloping down. And then in this last one, there's really no line that we could draw. The data is all over the place. So in this case, we'd say there's no relationship or no linear relationship. All right, so if you were to look at this example and I asked you, what type of relationship do these points have? Positive, negative, or none? What would you tell me? So if you want to go ahead and answer in the chat box, I can see, or if you want to raise your hand, I can unmute you.
It's positive.
You are correct. And it looks like a few people responded positive. So the slope, if we were to draw a line, it slopes upward, which is a positive slope. Good job. All right, so now we're going to talk about a line of best fit. Does anyone know what that is? So if we were going to draw on a line for these data, we're going to do a line of best fit. We're going to do it by hand, so we're going to eyeball it. You can do it with like a graphing calculator to get the exact value. But if I was going to draw a line of best fit, I'm going to draw on a line that I think fits this data the best. So I wouldn't draw it down here. That would be wrong because it's nowhere near the data. I wouldn't draw it up here. I wouldn't draw it like this. Basically, a line of best fit is going to be the line that goes through the data that you think fits it the best. That's why it's called a line of best fit. All right, so in this example, they have already plotted the data for us and they want us to pick which one of these would be the line of best fit. So we have to go back and remember about writing equations of lines. So this should look familiar to you. So has everyone seen y equals mx plus b?
Yes.
Yep. So does anyone remember what does M stand for?
Slope.
Good. So M is the slope. So if we look at our picture, if I was going to draw on a line, something like that, is our slope positive or negative?
It's negative.
It's negative. So if we look at our answer choices, we know it can't be 1.9 because that's positive slope. What's the slope in this D? Or this last one?
0.7.
So that's not positive, so we know it can't be that. So it has to be one of these. And then we're going to look at the B. Does anyone remember what the B stands for?
B is y-intercept.
B is the y-intercept. So that means about where it crosses the y-axis here. So if we look, our choices are 1.9 or negative 3.8 because it's minus 3.8. So if we look at this picture where I drew my line, that looks like it's about at 2. So which one of these would work? The first one or the third one?
.8 or
so now remember, this is minus 3.8, so it'd be negative 3.8. So negative 3.8 would be down here. And positive 1.9 would be about right here. So which one looks like it would fit my line the best? Positive 1.9 or negative 3.8?
positive 1.9.
Correct. So does that make sense to everyone? Does anyone have a question about that? Okay, so that's one way, to answer a question just by looking at, you have to know the slope. When it's a multiple choice, you have to find the slope. Well, we can see it's negative, so that brings it down to 2, and then look at your y-intercept. We can see it's positive, so that brings it down to 2. The other way you could do this is you could pick 2 points on your line and find the slope and pick which one it'd be closest to, and then find the y-intercept. So let's do another one. Okay, so in this question, it says the scatter plot shows how many cups of hot chocolate have been sold at a ski resort based on the outside temperature. Use the line of best fit to predict the number of sales if the temperature is 10 degrees. So we can see this. They have their data plotted. They drew in the line of best fit. You always, when you look at a graph, you want to look at what is it representing. So it says the title is hot chocolate sales. The x-axis represents temperature, and the y-axis is cups sold. So that's cups of hot chocolate sold. So it wants to know if it's 10 degrees out, how many cups of hot chocolate do we think we're going to sell? So take a minute and everyone think about that, and then we'll go over it together.
I have the answer.
Okay?
If that's okay.
Don't tell us yet.
Okay. By the way, my name's Vanessa, in case you were wondering.
Okay, I was just going to say, which one were you? And I can see your name in the chat box.
I'm Vanessa.
Hi, how are you?
Good, how are you?
Good. All right, so everyone's had an opportunity to look at this. So 10 degrees, that means we want to find the 10. And we want to know what's our line of best fit. Tell us about how many cups of hot chocolate. So you're going to look, here's where 10, if we followed it up. So what was your guess, Vanessa?
85.
85 would be fine. If you said 84, 86, anywhere around there would be good. Okay, so now let's look at another example. So this is, they want to know what type of relationship this would be. So it says Ling plans to collect data and plot them in a scatter plot to look for a relationship. She will compare the plane in the basketball game and the number of points scored. what type of relationship would you expect Ling to see for her scatter plot? So take a minute to think about that. So if you were to have a graph, it says she will compare playing time in a basketball and the number of points scored. So if this was your playing time, points scored. So do you think that data would have a positive relationship, no relationship, or negative relationship?
Positive.
Positive. How come?
Because time and points go up, basically.
Right. Good. So you would expect if you played, if you didn't play at all, you're not going to score any points, right? If you, played for 5 minutes, you might score a couple points. If you played for 10, you might score, 8 points or whatever. So it makes sense that the more time you play, the more points you would score. So that we would say would have a positive relationship. All right, one more, and then we'll go on to questions that you guys have. So it says, based on the collected data shown in the scatter plot, so I don't know who but he uses the linear model C of S equals 8.S plus 0.29. That's hard to see, so let me write that. According to this model, about how many service calls will Roger have in the next storm if 4.7 inches of snow fall, round to the nearest tenth? So let's look at this graph and look what it's representing. So it says snowplow service, amount of snow, service calls. So this graph represents, let's just say Dan. How much snow falls, that's how many service calls Dan is going to have. So if we look at this, it says 4.7 inches of snow. So that would be about right in there. So it looks like he'd have about how many service calls?
About 4.5, I'd say.
Okay, so you say about 4.5, which looks like a good estimate. But since they gave us an equation, we can use this to figure out the exact amount. So S is service calls. So we want to know 4.7. So what are we going to put in for S? 4.7 plus 0.29. So if anyone has a calculator, go ahead and put that in and see what you come up with. So 0.8 times 4.7 plus 0.29. So do you want to get the answer for that? You can either type it in the chat box or let me know.
Sorry, could you repeat that?
So I asked if someone had a calculator, if they could plug this in to get me the answer. So you're going to do 0.8 times 4.7 plus 0.29. This right here.
Okay, 1 minute. It should be, I think, 37.89.
Did you do 0.8 or 8?
Oh, I did A. Okay, sorry.
Yeah. All right, Celeste says she got 4.05.
Yep, I got that too. 4.05.
Okay, so that looks about good, doesn't it? Because the graph doesn't look at, it crosses about 4 here.
Yep, looks good.
And it says round to the nearest tenth. So if we had 4.05, what would that be to the nearest tenth?
The nearest, like, the nearest 10th place.
Yep, nearest 10th place. So 4.05 would round to 4 point what?
4.1.
4.1. And our label would be inches. Or sorry, no, service calls. So if you had 4.7 inches of snow, you'd imagine to have 4.1 service calls. And really, in this case, it wouldn't make sense to have 0.1 of a service call, but they did say round to the nearest 10th. But in real life, I think we'd say about 4.
Yep.
All right. So now I'm going to open the floor up for questions, any math questions that you have. So I'll just go through. Celeste, do you have any questions that you want to go over? Like pertaining to anything? Could be geometry, algebra, financial math.
Since you said geometry, I do have like one question.
Okay. Hi,
So
Kat.
I remember what sorry, what'd you say?
Oh, someone just came in, so I said hi.
Oh, okay. Yeah, I remember when I did geometry, when we did like almost like percentages or what do you call it? I think like angles and stuff. That's kind of
Yeah.
something I
Yeah.
had questions about. I forgot exactly what it was, but
So are you working in geometry right now?
no, that's probably why I kind of have a hard time telling you exactly what it is.
Oh. So yeah, because you could have angles and triangles. You could have angles like with lines, you know, like finding the angles, like those angles.
Yeah, it was like not circumference, but it was like basically figuring out almost like the inside, like it had to do with radius and circumference.
Oh, like arc length maybe?
Yeah,
Or,
yeah, stuff like that. Yeah.
okay. So do you want to go over that, or you just were bringing that up about?
Oh, if you don't mind, if we could go over, it, that'd be nice.
Okay, so are you talking about like in a circle?
Yeah, yeah.
So sometimes they want you to find like the length between 2 points. So like this is called, like if they wanted the length of AB, that's called arc length.
Yep.
Okay. And sometimes you'd see it represented like AB with the curved line over it.
Yeah, yeah. Right.
Okay. So in order to do this, you'd have to have a radius. So in this case, I made it up, it was 8. And you'd have to have an angle measure. So let's say this is 95 degrees. So to get the circumference, if we wanted the whole circle, the formula for circumference is 2 pi times the radius. Well, what's the radius for this circle?
8.
8. So we could do 2 pi times 8, and remember pi is about 3.14. So if someone would multiply that out, let me know what that is. So 2 times 3.14 times 8.
It's 50.24.
Okay, so we'll say 50.2. Now that would be the whole circle, but we don't want the whole circle. We only want this part of it. So what we're going to do is we're going to multiply by 95 out of how many degrees are in a whole circle? Does anyone remember how many degrees are? 360, yep. So we would only want like a proportion of that, just like if you ate a quarter of your breakfast, 1/4 of the piece of toast. We don't want the whole circle. We only want this portion, and we know that takes up 95 degrees. So that's why we do 95 out of the whole, which is 360. So take 50.2 times 95 divided by 360. What do you get?
It's a really, really long number, but
Let's round it.
13.247,222 repeating.
All right, what was the first part?
13.247.
Okay, so we could say 13.2. And I didn't give a label, but let's say it was inches, so you'd say inches. So the length from A to B is 13.2. All the way around, we said was 50.2. So does that help?
Yeah, thank you.